Okay, so thanks. Thanks for being here this evening. Thanks to the Develer and all the people that are working in actually organizing this conference. It's really nice that we have such a thing here in the south of Europe, so we can actually enjoy the nice weather finally. My name is Alexandra Betouni. I have been working with Qt and QML for several years now, starting from the university where I was developing applications for the BlackBerry 10 OS system, and actually one of those got awarded after several years. And then I joined Pelagicor, where I was working on building prototypes for medical devices that were actually also got a UX award after many years. And then I started working in automotive projects with companies like Daimler and so on, so in really large scale projects using Qt. So I'm here today to share my experience with you, my experience from the automotive industry. So I'll try to do my best showing you how it looks like working in such a project. Developing a car HMI, let it be a prototype or a product, a real product, and starting from scratch. But first things first. So cars. We all know what cars are, but from a consumer's perspective. But what do they really are from a designer or developer perspective? So cars are generally meant to be moving all the time. And they're moving, all of them in the same space, and they're driven by humans. So that means that safety and security is 2 points that we really have to pay attention when we are developing such systems. Also, as the space they're moving is a public one, there are several rules that we have to follow and to comply with, and also we have to consider that these rules are not the same between the countries. So it's not the same if you drive in Asia or in Europe or in the United States. So we have also to consider market variations. In a few cases, we want also to provide luxury to our clients. So we want them to give them the sense of importance. And of course, we have to consider comfort. Many of us are spending many time with our cars, so we have to feel comfortable when we are driving those. Of course, it comes then the personalization. We humans are tempted to personalize everything we use, mostly like from our homes to our mobile phones or laptops, etc., and of course our cars. And we have to think about intuition. So we have to consider making our user, making the whole process as easy as possible to our user. And of course, we need to have features, many features. So all these points are falling back to this. User experience then. So what is user experience? It has to do with the look. So it has to provide credibility, trust, harmony, and spirit to the user. So talking about safety, security, and compliance. Sorry about that. Okay, I don't know what happened. All right. Has to do with the feeling, so and the joy of use, interaction, and reaction. So comes back to the luxury and the comfort. And of course, the usability has to be useful, like when it comes to functionality, individuality, predictability, and so on. So personalization, intuition, and features, of course. But what happens now? Meanwhile, the user experience is the alpha and the omega of when it comes to a project that especially uses a user interface. It can be a bit problematic because it tends to become chaotic. And now let's see why. So that's the UX design iteration workflow, where in an ideal scenario, the workflow would be like that. So we design a concept, then we implement something, and that's it. But it's never like that. Usually it tends to be that the designer has a concept, then we go to do some implementation, and then we test that, And then we have a concept refinement and then test again, and the ball can be rolling always. So now, that was the theoretical part. What does this mean in practice? So usually when such a project is kicked off, then the designers will sit together because they have to decide and define the specifications, context, and the behavior of the whole HMI. So then after a few days, the designer will come to us, the developers, and he will start explaining how we should develop the HMI. So basically, the discussion will look like, hey, we have developed the first, the welcome UI animations and transitions. We have also several images and icons that you should integrate into the project. We have implemented different styles, and each style should support several themes. We have 3D content that it looks pretty cool, and that should go into an application. We have implemented the first version of notifications, pop-ups. We have applications like navigation, media, radio, connectivity for Bluetooth so that the user can pair his phone with the car. Oh, and right, we want to integrate social media as well to the car. And we want to have third-party apps so that the user can have Spotify and Netflix on the car. All right, and we have thought about as well, like very important, the current system settings, application, and localization, because we need translation support, of course. And all right, we need a virtual keyboard. And of course, very important, safe rendering, driver distractions, and so on. So when this guy stops talking, then we are like this. Of course. So eventually we have to sit down and think about the impacts on hardware, memory, processor, graphics, dependencies, development time, and deadlines. And after we have concluded with all this, then we have to come up with an architecture that can support all this. And of course, it's really flexible and it actually stable. We have to think about the reusability as well, because there are many cases that we built something, we built a UI, but we want to be able to use it also on another car, because we want to test something, or the difference is really small. So reusability is a really important topic. And also we have to think about change requests. What does this mean? Designers are usually not satisfied or never satisfied with the first version of the UI. So they usually come back. And the show is starting again. Hey, we have updated the 3D model so that you have updated to the software as well. We have updated and added some more animations. We have now new assets. We have more styles and themes. We have integrated a voice assistant. And we have several custom input methods for virtual keyboard. We have new style for pop-ups, new applications, features, features, features. And we, once again. So then, once again, we have to sit down and find out cost on the hardware, memory, processor, graphics, dependencies, development time, deadlines, architecture, reusability, change request, etc. And we have actually one more design iteration, and those can be really many. So automatically, we know that as developers, we have to be very flexible. And the technology that we're going to choose has to be very flexible as well. So now we're coming on the what technology part. If you ask me, is Qt suitable? Yes, of course. Actually, I cannot think of anything else currently that we could use for such a project. And some of the basic points, as Tiago said this morning as well, It's not only about graphics, it's a complete UI framework, supports animation, shader effects, 3D, etc. It has QML, so that enables us to develop fast and easy the UI and also iterate with the designers this way. It has C++ also for performance. We really need the performance for such complicated system. And of course, very important that we have interfaces for CAN bus, which is heavily used from cars for the communication with the car parts, like the mirrors or the doors and so on. Bluetooth for phone pairing, as I mentioned before, network authentication if we have to download anything from any secure server, for instance. Also talks natively to the hardware and basically one of the most important cross-platform, meaning that the same software that it runs on a car, I can actually run it on my laptop as well. And I can do the daily development on my laptop and test the same software on the car, very important. And of course, prototype to production. We can sit down with designers, build something quickly in QML, and when and if they're satisfied, then we can take this to the product. So, right, we have seen so far how is the workflow from actually the UX design perspective and how is usually the relationship between the designers and the developer. But now let's see what is really under the hood. And I have chosen to give an overview of the Qt Automotive suite, which is the Qt's current solution when it comes to the HMI development. And it's actually, I have personally worked with it, also on projects and also contributed to it. And in my opinion, it implements a really generic architecture, which is very flexible and modifiable. So it can be used not necessarily in automotive projects, but generally in projects, and also not necessarily with the Qt Automotive suite. Anyway, for whoever doesn't know, the Qt Automotive suite is a set of software components and tools to enable development of an IVI system. That means that it has libraries and components that we can use to create our UI, our interface. And also, in addition, it includes Neptune UI, which is a reference UI for embedded platforms for cars, basically, actually. And includes example applications and also an application store where you can download other third-party applications. So some general information, it's actually only available, although it's open source, it's only available under commercial license. And it's built on top of the Qt for device creation. Currently, we have version 5.12, which was released a few months ago. And it's a joint product between KDub, Luxoft, and the Qt company. So a rough diagram, that's Neptune UI. This is an instrument cluster, and that's a center stack console. And this is an Android application that it contains just for remote control for properties like changing the theme and so on. Now speaking about components, this is our HMI UI, the system UI, the applications, and also we can have second and third party applications. All these applications and in general the Surface windows are managed by the application manager. That's a module which comes with Automotive Suite, but also it can be used separately. Below those, we have the Qt IVI layer. This is taking care about the harmonizing the communication between the backend and the frontend. And there goes the middleware with Genevi, AGL, QNX, and Android, and of course a selection of possible supported target platforms. Other than this, we get whatever Qt for device creation brings. And Here are the additional Qt components that are actually used for the development of the Qt Automotive suite. So Qt 3D Studio is used for a car 3D model, which is integrated in Neptune UI. As an example on how you can actually do this. Safe Renderer is used, GammaRay and HumanLife. And also the Qt Creator for remote deploy and debug, and the Qt Profiler. I will explain these individually in separate slides. Starting with GammaRay. So GammaRay is an introspection tool. This is used to debug and profile complex Qt applications. Mostly when they have state machines or lots of JavaScript actually. And it's really useful because it works both on desktop and the embedded target. Things are always different between our desktops and the embedded target, so it's really good that we have a tool that works there as well. It's a free software and it's developed by KDAP. As general information. Then we have the QML-Live. The QML-Live, it's a live reloading system for Qt Quick that allows us to make changes in a QML document and see those in real time. So technically that means that we can work on a QML document on our Qt Creator and having QML-Live next to it, having the same document loaded there, and we can basically change the color, for instance, and save the document on Qt Creator, and we will see it reflected immediately. So that really speeds up UI development, and yeah, again, when it comes to designers, that's really fast iterations. That's developed by Pelagicor, and it's open source. So we also it uses it uses also the Qt 3D Studio, which was done just for your information, NVIDIA's contribution to Qt. So it was named NVIDIA. Oops, sorry. Right. NVIDIA Drive Design Studio, it was used to name before, and after it has been contributed to Qt, then it has gone through some modifications and adaptations, and it was renamed to Qt 3D Studio. This is basically a separate editor and engine, and it's meant to prototype 2D and 3D scenes, UIs. It provides us built-in material and effects library, so that makes it handy. And we have also the possibility to import assets from popular tools like Blender and Maya. If you have done anything in 3D, then for sure you will know those. Currently, it's a member of the Qt UI design tools family, and it's open source and commercial. So now coming into the more important and specific stuff, that's a Qt Safe Renderer. That's basically something new, relatively. And it's used to prevent physical injury or damage to the people. What does that mean? The instrument cluster of our car has some icons that they indicate the state of the car. So like battery and other very important information that we as drivers need to know all the time. So we need somehow to guarantee that these icons will be always there even though the whole system has crashed. And that's what the Safe Renderer does by separating those safety critical components and having them running on their own RTOS and their own memory, actually, so completely independently from the rest of the system. This module is only available under commercial license. The QtDay VI, as I said, it's for harmonizing the communication between the backend and the front end. It brings a level of standardization in order to access the backend services. So that means that we can actually use the same software in many platforms. So this also decreases costs and it's time saving. what it does technically, it provides C++ and QML interfaces to support standard features like media, radio, climate, which are really standard features for automotive, actually, but it also gives the possibility to implement new ones using manually or using a code generator like the QFace. Very important is that it works with real backends, but also simulators. So when it comes to the daily development, I cannot have a car next to my desk to test what I'm doing. And of course, it's also always very difficult to even have the head unit itself, because the number of head units that are available pre-production are always pretty low, like 5 or so, and the developers can be hundreds. So we have to use such things so that we can have a mock backend and we can test the software on our laptops. It provides plenty of reference APIs, and it's actually open source. Right now, the Qt Application Manager. The Qt Application Manager is built on top of Qt Wayland, and it's providing multi-process GUI architecture, not necessarily to the IVI system, but also to an IVI system. That means that each application runs on its own process, and this way we eliminate the dependencies between the applications, between the system UI and the applications, and also between the code, of course, and the teams. That's very important. In Neptune 3 example, the system UI is a separate QtQML application, but it's, however, a special one because it uses a Wayland server Qt platform backend, enabling it this way that turning it this way into a fully compositing window manager, and for this reason it can actually handle 3 windows currently. The center console I showed you, the instrument cluster, and a HUD window. And it can take up to unlimited. The other applications like media, radio, and so on, they are just showing up as simple QML items, and the system UI takes care about positioning those on its QML scene. Those are using a Wayland client platform backend instead. Right, there is also a Qt Application Manager plugin provided for Qt Creator. This is just facilitating the process by just automating things so that we can use an Automotive suite-based project with our Qt Creator and deploy to the target without having to do many things. That's the UI, basically, how it currently looks like. It's a complete example of an Automotive UI. So we can see like home button, car settings, and other, the application launcher in general. It has a calendar app, a media app, phone, and map application. All these are, sorry about that. Right. All these are separate processes. And it also has a climate, which is fake, actually, if you run it on your laptop, of course, but it uses a mock backend. And it's also a different application. That's the instrument cluster, and it uses the safe renderer. So I'm not sure if you can see this icon there for lights. This is rendered by the safe renderer. And that's the HUD window. That's the Android application I mentioned in the beginning, and this is it's the same UI actually, but I'm just showing you the 3D integration it has. So right, Neptune consists of 4 parts: the sender stack screen, the instrument cluster, a HUD, and the Android application. And it makes use of Application Manager, Qt IVI, Safe Render, 3D Studio, HumanLife, and GammaRay. Now, that's a more detailed graph about the architecture used. So we have there the telltales, which are the icons on the cluster. This is how they're called. That they are rendered by the safe renderer, and we have the displays. We can have up to unlimited, so that's why it isn't here. Now, when it comes to Neptune, that's the whole UI. We have the compositor UI. It's called System UI, and the applications that Neptune brings, and the home screen UI. And of course, the customer can implement his own applications and integrate those in Neptune. Then we have the QtDay VI core and our backend below. The features and the OS. Here we have Squeeze. That means that we actually can use Squeeze to test our UI. It's compatible. We can use Qt Creator and 3D Studio. We have the Application Manager plugin for deployment, and HumanLife for UI development, and the GammaRay plugin for profiling and debugging. This SDK installer is a plus of Qt Automotive Suite. What it does actually is when we work in such projects, they tend to be really custom and really big, and the team is also not sitting usually in the same place, not even in the same country. So that SDK feature gives the possibility to build a custom SDK from our project and ship it to the team so that it can easily install the project and continue working from there. Right, so just in a few words, what are the examples that Neptune brings? So we can see examples for UI animations and transitions, and very important in a multi-process environment, which is not the same as in single process. For application management and lifecycle. As we saw, we have a fully function, at least media and map applications. The map application is using Mapbox plugin. And we also have a radio sample application. Third-party downloadable apps. So Netflix and Spotify can be downloaded and rendered in the UI. We have the 3D content integration. It supports notification. It has actually a framework for notifications and pop-ups, and many other. Right, so concluding, as in Neptune, Qt can be definitely used for such projects, but even the best tool can be slow if it's abused. We always have to be conscious for what we are doing and how we are doing that. We have many possibilities, but we always have to keep some boundaries and limits. Like separating the logic from the UI, it's very important. Like keeping the HMI dependency free, because we can end up one day that the project crashes somewhere randomly because there is a dependency to a radio button. It has happened. It was crazy. We have to test regularly and make sure that we set up a proper continuous integration infrastructure. So if we miss testing something, that this does it for us. And it's nice that we do incremental releases and with regular testing on the actual hardware. And also, right, align software development practice and rules, and most important, design with software development. So that's it for me. Any questions?
Any questions?
I was very convincing, so.
Tired, maybe.
Nope.
Okay, thank you again.
Thank you.